Well, hello everyone, and welcome to the latest exciting instalment of the Festive Tech Calendar 2021. My name's Mark, and I'll be attempting to give you some sort of example of the basic idea of quantum computing through the medium of Christmas and Santa and elves and, well, maybe a little bit of mulled wine. Right, so I want you to imagine Santa. It's coming up in the run-up to Christmas Eve. For some reason, Santa always has problems coming up to Christmas Eve, and sure enough, this year again, he's got a big problem. He's lost the recipe book. That's the big important recipe book with all the big important magic recipes in it. And specifically, that book contains the secret recipe for the magic reindeer food that he gives to the reindeer on Christmas Eve to give them the energy to fly around the world in one night, and indeed to be able to fly at all. So he gets on the blower and he calls up the oldest and wisest elf. And he tells the elf, "I've lost the recipe book. How am I going to make the magic recipe? I can sort of remember what the ingredients are. I can sort of remember how it was cooked. Some of it was boiled, some of it was fried, some of it wasn't cooked at all. But I can't for the life of me remember what order it happened in and how long everything took. And we need to know that recipe so that we can get the best energy level so that the reindeer will have the energy to deliver all the presents in one night. How are we going to sort this out?" Fortunately, the oldest and wisest elf is a bit of a whiz with maths and organic chemistry. So he understands how to express that problem as a multidimensional equation. And he knows that if he can take that equation and find the minimum value, looking at the graph of it, then where that happens will be the best recipe for powering the reindeer. But there's way too many combinations and way too much calculation to do for a normal computer to work that out in time. So what does he do? Well, he's got a lot of elves in the workshop. And what he can do is he can give an elf a chocolate coin, which never goes wrong. In fact, what you can do is you can give quite a lot of elves each a chocolate coin. And now there's two little known facts about elves. Now the first thing about them is that they have telekinetic powers. So what that means is they can actually affect the chances of a coin toss and how likely it is to land head or tails. Second thing to know about elves is that they are psychically linked, so they can communicate with each other. That's why Santa hired them, because they work very efficiently together. So, what the wise old elf does, with his mathematical knowledge, he gives them each of them some instructions about how to work out what the chances of their coin landing heads or tails are. And then the elves, they all link together, and they put all these instructions together to come up with the overall chance of the possible combinations of heads and tails that they'll all land on at the end. So, when they all toss their coins, and the wise elf asks them to tell him what their answer is, he knows that given that he's given them the right instructions there, in the right way, he knows that the final answer will have a very high probability of being a very good recipe. So he goes off, tells the elves to land the coins, and they give him the whole heads and tails answer, and he translates that back into a recipe. And that recipe means that Santa can make the tasty reindeer food. It means that he can feed the reindeer, and it means that they all get energized up, and then the reindeer can travel round and get round to all the children in one night. Hooray! And in fact, it's so good that Santa even manages to stop for a minute for a cup of tea. So, just in case you didn't immediately get what was going on there, here's a quick rundown. So, as you may have guessed, the wise old elf is a quantum developer, and the elves in the workshop are what are called qubits in a quantum computer. So they're doing the actual calculations. So a quick rundown of the basics of quantum computing is it's very good for working on problems with relatively few inputs, relatively few outputs, but a huge amount of computation required to get from the inputs to the outputs. So it works very well, for instance, for simulations, like simulating chemical compositions and processes. And it also works well, as we were doing here, for some optimization problems. What it's not for is doing classical computing work. So, you're never going to have a quantum computer running a website. You could think of it more like a GPU in that way. It's designed to do specific work extremely well. Now, of course, the hard bit is to actually take your problem and turn it into a quantum solvable form. So that's where the mathematics side of things comes in, is taking your problem and expressing it as something mathematically that you can then address using the quantum computer and the qubit way of doing things and the probability-based high chances of getting the right answer thing. Now, obviously, quantum computers aren't quite there yet. There are some physical quantum computers, but they don't have an awful lot of power. And if you're doing quantum development, then there are quantum simulators and emulators, which can simulate a very small number of qubits, so enough to get the idea of what's going on, but not really enough to do anything any better than you would be able to do on a normal computer at the moment. But that's the basic idea. Specific problem solving, and in the future you'll be able to solve those sorts of problems really, really quickly. If you want to find out more, you go to azure.com/quantum. And with that, I will return you to your mince pies. So thanks very much for watching, and maybe see you again next year. Bye.